Hey guys, I wanted to do another video for you on some updates I've done to the Foundry. Again, this is my direct melt tilting waste oil foundry. That means I do not have a crucible in here. I melt directly inside of the refractory in the furnace itself, and then it tilts to do my pour. I'm going to go through this video, and I've actually only shot about 1 minute and 23 seconds of video. So what I've done is I've looped the video a whole bunch of times here, and as I go through each loop, I'll explain probably one particular piece each time I loop through, and then use that minute to talk about each item. So this was my intro. I'm telling you what I'm about to do, and then as the video loops through, I will give a lot more detail about each of the items that I want to talk about. There's an auxiliary fuel tank I've added, the peristaltic pump, the water settling tank, the air box, the table. Those are some of the main points. There's even a heat shield there that I've added to this foundry, so I want to kind of go through each of those in more detail and give you a better explanation of them because the video is very short. So here we go. We started over with loop number 1, and I'm going to talk about the auxiliary fuel port. This is a propane tank, a small propane torch tank that I cut the top off of. Be careful if you do that. You want to make sure it's totally empty. Goes down to a little needle valve, and I can put any fuel I want into there for testing purposes. You wouldn't believe it, but the foundry is actually running off of bacon grease right now in this video. I've got the, well, half bacon grease, half oil, but I wanted to test how well the bacon grease burned, if it caused any problems, so next time around I'll probably do a much higher level of bacon grease and slow down the peristaltic pump even more to let it just run off of bacon grease. We get a lot of bacon grease when we cook breakfast in the morning, and I always save it in jars. Pickle jar fits perfectly down inside of that propane tank, so I can kind of put it at a little bit of an angle and let the heat from the system kind of melts the bacon grease. It runs down inside, and voila, I have a free, limitless supply of fuel that I don't have to throw it away. I can burn it in the foundry, and it's great. So we're looping again. Here we're going to talk about the next item, and that is a water settling tank. My foundry in the wintertime ends up getting a lot of condensation in the fuel oil tank. It's just natural, it happens, you get condensation. So I added that little guy right there. That is a juice container with 2 tubes coming in the top, one on the left, one on the right, and then a tube coming out the bottom with a needle valve on it. What that does is my peristaltic pump pushes fuel into the tube in the top center, and that's slightly lower than the other tube on the top right. So fuel goes in there mixed with some water and who knows what. The heavy stuff, the water, will settle out to the bottom, and the light oil, the fuel, will float to the top. So I get clean fuel coming off of my main fuel tank, even if it does have water and condensation in it. And then all I have to do is open up the little needle valve at the bottom every so often and drain that off into a container to get the water out. So it's a great way of separating the fuel there from any water contaminants. We're looping through now. The next time here we're looping through this video, and I'll talk about the peristaltic pump. The peristaltic pump was a necessary item simply because cold weather. There's a shot of the peristaltic pump, that little red light and that silver dial, and you can see the pump actually turning maybe at about 60% speed right now. 50 or 60% speed. It can go a lot faster than that. But the fuel in the winter starts flowing very, very slowly. We're talking molasses slow, and that just won't do if you're trying to, do a gravity-fed system into a foundry. couple weeks ago when I shot video of some friends over helping me do a pour, it took us 3 hours to get up to temperature to finally do a pour, because it was just, the fuel was flowing so slow I couldn't get up any heat. Now with the peristaltic pump I can instantly get up to whatever heat I want, and we're talking you could be up to melting temperature inside of 15 minutes here from a cold start. So the peristaltic pump's great. It actually has a little switch that I can go from forward or reverse, and the little silver knob lets me control the flow rate. Alright, next item I want to talk about. That right there is the heat shield separating the important stuff that's happening, all the fuels coming in and the air coming in, from the red hot fire extinguisher or burner tank. And the heat shield keeps everything behind it pretty much safe. I've done testing with my infrared thermometer, and believe it or not, things on the back end of that are, 70 degrees, 80 degrees, and on the front end it's well into the 190 degree temperature. So it's pretty amazing how that little piece of sheet metal protects it. I'll talk about the table here. You're looking at that table in the front. I do show a couple shots of the table in other videos, but I made that table with 3 legs, one in the front, 2 in the back, and kind of welded a piece of bar stock onto a nut, which gave me 3 T-nuts. I can loosen the T-nut and then extend the leg, retighten the T-nut, and it's perfect. It allows me to get that table perfectly level. That table is supposed to support sand molds. It's not for pouring ingots. I'm going to build another apparatus on the front for pouring ingots after the sand mold is poured, but for now I use it to do my ingot pouring. So let's see, I've talked about the auxiliary fuel tank, the heat shield, peristaltic pump, water separator, the table. Airbox is probably the last thing I want to talk about. I show video of how I built that airbox, but I can insert that board in vertically and go from 0% airflow all the way up to maybe 40% airflow if I would pull that board the whole way out. In that case, then it would be getting air, and the air would be delivered to the blower tube, and the rest would be just blowing out the top of the box. As I then insert that board, which you're about to see a shot of, horizontally like it is now, as I slowly insert that in, I can go from probably about 40% airflow all the way up to 100. And believe it or not, the last, probably from 70% up to 100 is achieved in the last inch and a quarter, because as you shut that last little gap, it ramps up almost exponentially, because you're just increasing the static pressure in the system there. So that's pretty much it. All of the items that I wanted to cover. I'll make more videos and talk more about it, and maybe I'll even do a video on the shelter itself, because the little building that I'm in that I built is specially constructed so that I can have things kind of from just coming outside to do Foundry work to being ready to have a fully protected area that's open in 5 minutes, maybe 6 minutes. I roll up the tarps and latch them up top and put up my sidewalls on the 2 front sidewalls, then I'm ready to go. Even if it starts raining or snowing, it really doesn't matter, because I'm fully enclosed. I'm unfortunately not showing any shot of that far enough back that you can see how it's all opened up, but you need to have a very wide open space and good airflow when you're doing Foundry work. So that's it. I hope you guys enjoy it. More to come as I build my sand muller and do more videos and start getting into actual sand casting in earnest. Alright, talk to you later.